Thank you everyone for joining me here on the webinar today. I'll be talking about data ingestion into cloud, into various systems in the cloud. So first, let's talk a little bit about what I mean when I say data ingestion. It's actually a very simple process. It's basically the process of collecting raw data from somewhere and loading it into some sort of a target system in our cloud. In our case, this will be in the cloud, while mostly keeping the same format as it is on the input. You'll have to map the data a little bit depending on your use case, but we are not talking about complicated data integration where you do some sort of complex operations on top of the data, but there are other about operations where you just grab the data from whatever the source is, apply simple basic rules, like for example, changing format, delimiters in CSV files or something to make your target system accept it and push it to cloud to your target. What is interesting about this is that this is a very frequent use case, right? It's also known by other names, like for example, data onboarding, which is very important, especially for various service providers who need to onboard their customer data, right? For example, if you are providing HR software or something similar, you need to make sure that your customers can load their data into your system effectively. So data ingestion or the customer data onboarding is very important. And it's of course important to make sure that it works automatically without issues. And when you are thinking about processes like that, you need to think about data locations and many other properties. And I'll walk you through various considerations for loading data into the cloud and through some approaches that you can take in different cases. So one of the things that you'll need to consider first is, of course, the data location. For the target, we are talking about cloud, so that a little bit limits our options. But when we talk about the data sources, the data can be pretty much anywhere. You can have data on premise, which is very frequent, especially during migrations or those data onboarding exercises, where you frequently need to load the data from various legacy systems or in-house applications. Or you can have data in cloud, which also can be a different cloud than your target, which brings its own challenges, for example, with access permissions and so on, and you need to make sure that your data is secure, even though it can be traveling halfway around the world. And since your data, if it's located in the cloud, it will often be stored in some sort of application where it might be a little bit harder to get to it because you often don't see any kind of a backend, right? You have usually nice front end, user interface, and so on, but you don't have any direct access to the database or file system or whatever the application is using to store the data. And with both options, whether you are on premise or in cloud, you have multiple ways of actually storing the data, kind of like data storage options. One of them, or the simplest one probably, is storing your data in files. And again, you have many options ranging from flat files like CSVs and similar, all the way to more complex data like XML, JSON, or even more modern format like Avro, Parquet, and similar that allow you to store more complex data. But oftentimes with these days, you get unstructured data, which is all kinds of media like pictures or even videos, audio, and so on. And these frequently need to be loaded into your target system as well. Very common use case is storing data in databases, whether it's a relational database, your traditional SQL stuff like MySQL, Postgre, Oracle, and many others. These tend to be very easy to work with. It's technology that's been proven over decades. So pretty much every tool that you work with will have some sort of support for databases. Oftentimes even various cloud applications can ingest directly from database. In last years, we've seen growth in NoSQL databases or non-relational data stores, like for example, MongoDB or various graph databases like Neo4j or others that allow you to do use cases that are oftentimes very cumbersome or annoying to do in a relational database. So these are usually accessed in slightly different way than the relational databases, but it's still pretty much the same way. You have some sort of query language that you can use. And finally, the most varied group is what I called applications in here, even though it covers stuff like really applications like SaaS tools, but also things like messaging queries and so on. So you can have all kinds of systems that are not that simple. They can live within cloud and usually needs to use an API to talk to the systems. And all of these can be either your data sources or your data targets, right? So depending on your use case, what you are trying to do, you'll usually be given a set of sources that you need to process, and then you'll have a target that you'll work with. An important point or important thing that as you are getting your data into the cloud is how you get it there. And not how on a technical level in sense, like, for example, whether you need to do an insert into a database or something similar, but rather what tools are you going to use? And there are, again, few options that you can take. On a simple level, you can use what I would call scripting. So you either write it in something like Python and SQL, R, and so on. Oftentimes you will be able to use some sort of like interactive shell that will allow you to run this kind of languages. So you can type and you get results immediately. And while this works, it's also often not very sustainable and not something you want to maintain in production. So many users we've seen over the last years move to either what I would call data loaders. So fairly simple tools that are oriented towards business that allow you to very quickly load your data into cloud with just a few clicks, like Stitch or Matillion Data Loader. You select your source, it gives you a list of data that you can see there. You select subset of that if you want, you give it the target, and that's it. The drawback in here is that these tools tend to be fairly simple, which is kind of their design philosophy. So they don't allow you to do any transformations, or if they do, it's very simple. They often have very limited number of data targets. For example, Stitch and Matillion both load into cloud warehouses. You can't load into an API, for example, and so on. But for many use cases, this is just fine, and it allows you to do something very quickly and easily. If this is not enough for you, what you'll need is what I would call full data integration package that allows you to implement pretty much any business logic. You can talk with any source or any target system. You can implement complicated transformations and so on. There are many tools on the market that you can use. One of them is CloverDX, which is a tool that we provide, but of course you can use something like Informatica, Talent, and many others, right? You can always pick whichever works for your platform, or especially your budget if you are talking about some of those. And since I will use CloverDX as an example in some of the slides that I'll show later, CloverDX is a data management platform. So this is what we do. We've been doing this for about 20 years now. And the benefit of Clover is that it's a very flexible tool that you can deploy pretty much anywhere. And it allows you to connect with pretty much any data source or data target. So whether you need to load files from on-premise or cloud system, you need to write files, databases, or APIs, you can do that very easily. We can easily implement complex scenarios. For data ingest, this is often not that necessary, but oftentimes these use cases tend to grow into something more complex. So Clover will be able to serve you very well there as well. And of course, you can automate everything. So you don't have to push buttons or click on anything to get your data loaded, which is frequently what you want for data ingestion, because you need your data to get into cloud regularly, for example, to keep your data warehouse or data lake up to date with your source systems. And oftentimes you'll have to deal with messy data, and Clover can help you there as well. A little bit about the architecture, so that when I talk about how we do in Clover, you understand that. So Clover is essentially made out of two pieces. One of them is called CloverDX Designer. This is the development side of the platform. It's basically a development environment where you create all your transformations. It's very visual. You kind of move boxes around and connect them with arrows to designate your data flow. And when you want to deploy that, when you want to run it, you deploy it to what we call CloverDX Server, or a cluster if you are going for large data volumes. And this is something that you can install either on premise or in the cloud. And this is where the data processing happens. And the server will be the piece that will be connecting to your data sources and data targets. So of course, it provides all of those connectivity options, whether you need databases, files, web services, APIs, or anything else. Now, when you are thinking about picking the package that you are going to use for mapping or transforming your data on the way to cloud, you'll realize that you have one more choice. Not only you need to pick the software that you'll use, but you also need to pick what I would call style of your process, whether you are going to push the data or you are going to pull the data. Data push is an interesting approach. It means that you locate your data processing to like Clover near your source. So for example, if your source is on premise, your Clover instance will live on premise. If your source is in cloud, let's say AWS, you install Clover in AWS and load into whatever you need. And you push data out from this instance. This is a very interesting approach because it's something that gives you a lot of flexibility. You can process your data in any way you want, and you don't need to open your source system or the network where it's located to outside world at all. You are just pushing the data out, so no open ports, no complicated network configuration or anything like that. This approach also works very well when your data source is complicated and, for example, stores large volume of data and you need to push just a small subset of that into your target. Oftentimes this happens with large APIs or something similar where you need to scan large volume of data to figure out changes because the API doesn't give you that. So you can filter down in your source system and you transport across the network only a small volume of data that gets into your target. On the other hand, what you can do is data pull, meaning that you locate your data processing near the target. In our case, this will always be the cloud, which makes it interesting, especially if you need scalability, but it's also a little bit challenging when you want to load data from on-premise systems, because it means that basically your data process needs to actively pull data from your source, which means that you have to open a port or open your network a little bit on your system to allow cloud to see the resources inside it. And while this is technically not complicated, it's also something that oftentimes results in errors or people don't configure everything properly and can inadvertently expose data they don't want to. So you need to be very careful when you do this. On the other hand, this is very interesting when you need to process massive data volumes in the cloud, because oftentimes you'll be able to take advantage of almost like infinite resources in the cloud. So you'll be able to scale not only your target, if it allows that. For example, if it's a database, it can scale in the cloud, but you can also scale your data processing to handle large data volumes easily. In both cases, you can accomplish the same thing, right? So whether you are doing data push or data pull, it doesn't matter. You will be able to accomplish the same, but you have to pick fairly early in the process of implementing your data ingestion so that you can make decisions about how to do it and so on. You can also do kind of combined approach, but that means that you'll need something also in the source and in the target, which oftentimes is just too complicated to set up and doesn't really provide any extra benefits. So now that we've talked about kind of the high level stuff, so you have the data sources, you have something that allows you to process data, and then you have your approach, whether you are pushing or pulling. Let's talk a little bit about how to handle different kinds of data when you are ingesting into cloud. So first, I'll talk about files, because at least to me, these are conceptually the simplest. So there are many different ways of working with files in the cloud, of course, right? Cloud provides many options for pretty much anything you do there. And there are few use cases that you'll see appear very frequently when people ask you to just load a bunch of files into cloud. The first and very common one is data lake. Oftentimes this is implemented just as a file system somewhere where you store your data. It can also be as a database, but oftentimes data lakes store files, raw extracts from whatever is the source system. So this matches the description of ingestion. Right? You get your data from your source system and without any transformation, really, kind of just formatting it to store in whatever file format is appropriate, you load it in your cloud storage. Oftentimes, these files, even when you load them into data lake, are used as a first stage for bulk loads or file imports. So this ingestion is typically or frequently a first step of more complex process. So you dump files into your storage in the cloud, and then something happens with them afterwards. It's not just for storing the files as they are. And oftentimes files in the cloud are used as storage for like websites. This is being more and more common, especially you see many websites that use content management systems that store data in S3. I'm not going to really talk about that, but it's a very important use case that you often need to keep in mind. And frequently, cloud is used as data backup. So again, you do something similar like for data lake, but you don't keep the data updated in the same way, but rather you do, for example, full dumps every day, or incremental and so on. It's really up to you. And this is again something I'm not going to cover, but it's interesting to kind of know about that. And there are, of course, different ways of how you can store files in the cloud. There are many different services or many different approaches for what you can do there. And the first one, let's say conceptually, the simplest one is what's called object storage, or oftentimes blob storage. This is a simple storage system that's optimized for storing massive volumes of unstructured data. So whatever you want to write into object storage, it will accept that. There are no schemas or anything like that, right? It's fully up to you to organize the data in the storage. The only thing it will do for you, or in the object storage, the only thing it will do for you is it will do it at scale. So it will very easily accept petabytes of data, millions of files. Each file can be terabytes in size, right? Depending on whichever cloud or whichever system you use. But there's a price, of course, to pay for that kind of simplicity and performance, that it doesn't have many things that you normally see in traditional file systems. So there's, for example, no support for directories. You get kind of that when you think about S3 or Azure Blob storage. They have buckets, right? In S3 and in Blob storage, it's called container. So they give you one level of hierarchy. And then to organize your files, you use kind of prefixes, right? So instead of having directories that are a different kind of an object on a file system, you just use a prefix of a name. And frequently you can use, like, for example, dash internally if you decide that dash is a directory separator for you. So if you have something on a deeper path, you just convert the name into something like this, right? So in my case, these are two files called 1 and 2 in a directory customer. And this approach of using prefixes is also something that's used by many tools that depend on data being loaded in object storage. For example, when you are loading into Redshift or similar databases, you can say just the prefix of the files and it will load all of them regardless of the suffix. So I would be able to say just load customer and it will load both files, and typically it will do that in parallel. Right? So it's a very simple system that allows you to do pretty much anything you need, and the goal is to allow you to store almost unlimited amount of data. And for most regular users, the file size or the overall volume size is effectively infinite. One level up from that is what I would call block storage. This is more like traditional file system, and typically it's used as a, let's say, a disk in various workloads. So you need to build, for example, a virtual machine in the cloud. So it's of course requires some sort of storage to store applications and data, and typically this is done as a block storage. So these are not usually visible from outside in any way, right? You can of course upload data in different ways, but you do not use this as a direct storage for files when you do, for example, data ingestion. And you can use it as a temporary storage because your ETL package might be running in the cloud and using block storage file system, but usually you do not directly write data into that. And again, there are many options for these in kind of each cloud provider. Azure, for example, provides something called Azure Files, and there's also Azure Disk. Amazon has two options, either Elastic Block Store or Elastic File System, depending on what you need. And so you can again pick depending on the use case that you have. And finally, kind of a little bit on the side, but it's good to mention this, is what I would call file sharing applications. So these are not really file systems because you typically don't see what's behind it, but it's something like Dropbox, OneDrive, or Google Drive. These frequently appear in like data ingestion use cases, but oftentimes not as a target, but rather as a source. They are not really meant for automation of this type, right? So as a source, they are fine because people typically use them to store their documents, pictures, videos, whatever. And you oftentimes need to load that somewhere else. But usually this is not something that you would want to use in an automated process, as for example, a staging area or something like that, because there's overhead of every time you have a client application that needs to synchronize your data. So you rarely write directly into these, although they do provide APIs that allow you to do that. And you typically write somewhere on your computer, and the client will make sure that it's synchronized with the cloud. So it's kind of cloud storage, but frequently not really used in the use cases that I have in mind in here. And as I mentioned, I'll be talking a little bit about Clover when talking about how to do these things. So in Clover, loading files into cloud is actually fairly simple. We have many different ways of doing that. You can either, for example, write directly into cloud storage like S3 or Azure Blob. You just need to provide URL of the file, and any kind of a file that you produce can be written like this. So for example, if you need to write a flat file, there's a component called flat file writer that does that. And instead of specifying a file location that's on your server, you specify a location that's in the cloud. And it will work fine regardless of whether you are in a different cloud, on-premise, or anywhere else. Right? So you can use this when you're doing push from anywhere, or when you are doing pull as well. And it works for different file types, and the components that write XML, JSON, or Excel files, they allow you to do the same thing. You can, of course, also do file operations, kind of manage the files without looking at their content. So for example, just copy file directly or move file if it exists already. And you can use these protocols there as well. Right? So you just kind of provide the settings, and Clover backend will take care of everything else. So it's very easy to configure, and it gets things done. Now let's look at a little bit more complex system, and that's working with databases in cloud. This is an interesting topic because there are many different databases you can install in cloud. And the first thing that you would hit when you are thinking about doing something with the cloud database is the distinction between fully managed and self-managed database. The fully managed is something like Amazon RDS or similar, where basically the cloud provider takes care of everything for you. So you just select type of a database that you want. For example, that you want a Postgre instance, you select the size, and a couple minutes later, a couple seconds later, you'll get your instance ready. You'll get an URL that you can talk to, and everything is managed for you. The drawback is, of course, that there are some limited options in here, because they will not allow you to install just any random database. They will have always a set of databases they can manage, because someone needs to maintain the infrastructure. And the configuration for your instances will be limited. So if you need something special, something very custom, you often will end up doing self-managed database, which means that you basically install or create a virtual machine somewhere, or maybe you get even a physical hardware in the cloud, and install your own database there. A benefit of this is, of course, that you can install anything with any configuration you need, even databases that are not supported directly by your cloud provider, or using the settings that they don't allow in their managed options. But of course, a significant drawback is that you have to do this by yourself. And not only installation, that usually is fairly simple and just kind of one-time thing, but you also need to manage the thing by yourself. And then, of course, there is a question of cost. This is something that's pretty much, or that should be pretty much on your mind every time you do anything in the cloud, because everything costs money. And in here, the cost is fairly hard to evaluate, right? Because you always end up paying for infrastructure, for traffic, and so on. But for example, with self-managed databases, you'll also need someone to manage your instances, meaning you'll have to have a DB admin or someone who manages the operating system or the virtual machine itself, and so on. While in managed database, this is done by the cloud provider. So when we talk with our customers, they frequently just go with managed databases because they don't want anything specific. And when you look at kind of what do you do and versus what your cloud provider does for you in different options or in different scenarios, is that when you use managed database, you basically take care of using the database, right? So you do your schemas, queries, and whatever you need to take advantage of your database. And everything that's kind of lower, below that, kind of lower level tasks like failover, backup, security, and all of that, that's managed by cloud provider, and you don't see that. When you do self-managed databases, you have to take care of everything except maybe for infrastructure, and they will maintain the actual physical servers, the network, and so on. But this, all of this maintenance and management is not free and can take significant amount of time. So, when picking whether to go with managed or not, consider your options, whether you need the flexibility or whether you just rather do this and have your life a little bit easier. Regardless of whichever option you go with, when you have a database in the cloud, let's talk about relational databases first, it will always behave the same way, right? It always exposes the same interface, and there are a few different ways of loading data into relational databases. A traditional way is to use simply insert statements, or if you need to modify something, you do update, delete, upsert, whatever you need. This is an approach that's very flexible and it works. It can be used pretty much in any tool that I've seen. Even when you do scripting, this is what you end up doing. You just run something that allows you to run your SQL statements. And there's drawback to this, and that's the performance. For large data volumes, you often end up with very slow data loads, especially if you are not very careful, because the latency between either on-premise and cloud or between two different clouds tends to be fairly high. So you need to make sure that you can batch your data as much as possible. For example, when you're doing inserts, you should use multi-value inserts, right? So instead of inserting one record at a time, you insert as many as you can to increase your performance. And this can be a huge difference, right? It can be orders of magnitude faster to do this than do one insert at a time. Another option that's not available all the time, but in some cases you are able to import large data volumes directly. So for example, you export your data from your source into a file that you load into your cloud. So this is where the first step of multi-step loads comes in. You load file somewhere into your object storage or into a file system in the cloud, and then you use command line tools typically to load your data into your database. This is less comfortable than using user interfaces to do this, but the performance is often worth it. So if you can do this and you have the option, then it's a fairly good option for getting your data into cloud. What is interesting is that when you then start thinking about cloud warehouses like Snowflake or Redshift, that on a first look, they might seem like they are a traditional database because they behave like that, and you can do select, you can do insert, whatever. But the data loads usually work fairly differently. You can still do your inserts and so on, but it tends to be very slow. These databases or cloud warehouses are optimized for large data volumes, and the data loads need to accommodate that. So typically the approach to do this is to do what's called a bulk load, which again is a two-step process where you need to load your data as a file into object storage. So whether, for example, S3 or Azure Blob or something similar, and then you instruct your cloud warehouse to load from the object storage. And this gives you a lot of benefits because when you do this, there's a copy command for both Redshift and Snowflake supports it, although with different syntax. The warehouse will be able to use basically all the resources it can. So for example, if you split your data into 10 different files and ask the warehouse to load them based on the prefix that those files have in common, it will create at least 10 threads and load your data in parallel. So this is something that can give you massive performance improvements over doing just simple insert or something similar. For example, when we were doing performance tests for some of our customers, when we were considering the approach, which one to take, the bulk writer into Snowflake is 8 to 10 times faster compared to just doing inserts, even when you are careful with what kind of data you upload and so on. And without optimization like compression or anything like that, you can probably get even more when you reduce the data volume a little bit more. So this is how you get your data into the warehouse when you just need to insert that. But oftentimes you need to do something more with the data. For example, you might need updates, or you might even need to delete some data from your database. And in this case, you can, of course, do insert, update, delete queries. But as I mentioned, these tend to be fairly slow. So what typically happens is that you run your workloads as an ELT, meaning that you create temporary table, you load your changes into that, and then issue an update query that will modify your target table based on whatever is in the temporary table. This is frequently done, for example, for updates and so on. Right? And again, the benefit here would be that since you are doing the heavy lifting in your cloud warehouse, it will scale, right? So it can add its own compute resources as needed, and therefore it will be completed faster compared to doing complex operations somewhere outside of the cloud warehouse and then just dumping the data there. And again, a little bit about Clover, how we can do that in here. So to do bulk loads, which is the preferred way of doing these operations, we have a native component for Snowflake, which can deal with Snowflake running anywhere, and whether it's in Azure, in AWS or Google Cloud. And we also have what we call a subgraph, which is kind of a custom-made component for Redshift. And both of them implement the fastest strategy for getting your data into the cloud. So they will load data into blob storage or into object storage, and then we'll issue the copy command with correct settings to make sure that the data is loaded in parallel as fast as possible. You can also, of course, access cloud databases in Clover directly. We have a component called Database Writer that allows you to connect to any database for which you have database driver, which means like Postgre, MySQL, Oracle, or even Snowflake or Redshift. And you can use this component to issue update calls, deletes, and so on. And we also have DB execute, which tends to be used for those ELT workloads where you write that T, right, the transformation that you do with your tables at the end of your ELT process. That's what you do in your DB execute component. And finally, let's talk a little bit about the cloud apps, or what I said is kind of the generic catch-all term for anything that's not a database or a file system. And frequently, the best way of doing the loads in here is through an API. Oftentimes, when you are talking about cloud applications, you mean something that's SaaS, right? Software as a service. And these tend to provide powerful APIs that allow you to work with data in those applications. You can often query and modify the data. Of course, the landscape here is huge, and different tools provide different kinds of APIs. Although most of them tend to be REST APIs, you can still find some SOAP APIs if you look hard enough. For example, if you look at Workday, that's a SOAP API. But when you look at HubSpot or other tools, they use REST APIs. And so you'll need an approach for calling APIs, which you can do in most integration packages fairly easy. One thing to always consider is that APIs tend to be fairly high overhead. Most applications do not provide APIs for bulk load in a sense that they allow you to upload, for example, 1,000 records at a time and do that with a single call, but rather you need to do 1,000 calls, one record at a time, which can, for large data ingestion volumes, mean fairly long time to load your data, because each call can have quite high latency. And if you try to run many calls in parallel and issue too many of them at a time, you often get throttled, right? Because those tools need to protect their resources so that every client that they have gets their fair share of the resources. And the approach is fairly simple. Again, I'm not going to go too much in detail because there's just too many different options for what to do depending on the API. But in general, you'll need to read your data and map to an API. And as I mentioned, the most popular style of API is REST API. So typically this means that you have to create some sort of hierarchical data, usually JSON, out of whatever source you have. And many sources will be like databases and similar, so they store flat data. So you need to map it to your JSON and then issue the API call and process the response, to figure out whether the call was successful or not. In Clover, we have components that allow you to do this. A component called, for example, HTTP connector allows you to do REST APIs or web service clients for SOAP APIs. All right, that's pretty much everything from me. Thank you everyone for joining me here and have a great day.